Hello learners! I hope the detailed discussions in the last program must have given you a clear idea about various sound equipments. Now, we shall learn about the electronic methodology which makes the equipments work. In electrical systems, current flow is proportional to pressure of the direct current, that is DC source. Like a 1.5 volt cell, mobile battery 4.5 VDC or car battery 12 VDC. Or alternating current, that is AC source, like AC power supply 220 VAC. Now let us know about voltage. Electric field is a region around a point charge within which its effect can be experienced. Electric potential of a point, say P, is the work done in bringing unit positive charge from infinity beyond the electric field of P to that point of P. Consider 2 points, P1 and P2, with potentials V1 and V2 respectively. If there is potential difference between P1 and P2, this is termed as potential difference, that's PD, defined as V equals to V1 minus V2. Most of the modern-day sound recording equipments operate on DC voltage sources, obtained either from dry cells or by converting from AC mains voltage. Emphasis in this lesson has been limited to DC voltage sources for easy understanding. Now let's understand current. And we can define the conventional current as the rate of flow of charge positive per unit of time. 1 ampere of current is flow of 1 coulomb of charge per second. Unit of current is ampere and is represented by letter I in the electrical circuits and calculations. Smaller units such as mA, that is 1 milliampere, equals to 1 by 1000 A, are most commonly used in electronic circuits. The magnitude of current flowing through a simple circuit can be determined by use of a most important basic law called as Ohm's law. Ohm's law states that the current in a DC circuit varies in direct proportion to the voltage and is inversely proportional to the resistance of the circuit. Resistance is represented by letter R and its unit of measurement in electrical or electronic circuit is ohm. Mathematically, this law can be expressed as current equals to electromotive force by resistance using the symbols I, V and R to represent current, voltage and the resistance respectively. Ohm's law can be written as I equals to V by R or V equal to I into R. It should be noted that this law not only holds for a complete circuit but can be applied for any part of a circuit provided care is taken to use the correct values for that part of the circuit. Also, that conventional current is considered to be in a direction opposite to the flow of electrons. Electric current flows through a path if path is part of a closed loop with an independent supply source. There are also important components used in electronic circuits. Components used in electronic circuits can be broadly categorized in 2 ways. Passive components. Resistors, inductors, capacitors, diodes, thermostats, varistors and transformers are examples of passive components. Passive components are those which do not produce or amplify AC signals. Well, the next is active components. Active components are those components which can generate or amplify AC signals. The example of active components are bipolar junction transistors, also known as BJTs, field effect transistors, operational amplifiers, analog ICs and digital ICs, that is integrated circuits. Well, ICs are devices which integrate thousands of resistor, capacitor and transistors to perform a desired function. Now let's study the passive components. Passive components can be studied as resistors. Resistors provide means of controlling voltage and or current in a circuit. Series and parallel combination of resistors. In some of the cases, it is not possible to have an exact value of resistor that is required in the electronic circuit. Exact value is then obtained by use of series or parallel combination of resistors In series combination, the resultant value of resistance is equal to the sum of value of individual resistors. Here, R equals to R1 plus R2. In parallel combination, the resultant value of resistance is given as 1 by R equals to 1 by R1 plus 1 by R2, or R equals to R1 R2 by R1 plus R2. Now let's talk about capacitors. Capacitors are passive components which store energy in electrical field. These components do not dissipate energy like resistors. Typical applications of capacitors include working as energy reservoir and smoothing circuits in DC power supply, coupling AC signals between different stages of amplifier, decoupling power supply from one stage of amplifier to another. Electrical characteristics of capacitors are determined by physical dimension and type of dielectrical material used in the capacitors. The capacitors are therefore classified according to the type of dielectric used, such as paper capacitors or ceramic capacitors. Both fixed and variable capacitors are commonly used in electronic circuits. The capacitors are represented by a letter C in circuit drawings. The actual measurement of a capacity of a capacitor is termed as a capacitance. The unit of capacitance is the farad and is expressed as C equals to Q by V, where C is in farads and Q is in coulombs and V is in volts. The farad is a rather large unit, so we use smaller units such as microfarad equals to 10 minus 6 of a farad, or picofarad equals to 10 minus 12 of a farad. There are also a series and parallel combination of capacitors. In order to get a required value of a capacitor as per circuit design, both series and parallel combinations are commonly used. The resultant capacitance of capacitors, that C1 and C2 in series, is expressed as 1 by C equals to 1 by C1 plus 1 by C2, or C equals to C1 into C2 by C1 plus C2. In case of parallel combination, it is expressed as C equals to C1 plus C2. There are many factors which should be considered while selecting a capacitor for a particular application. Required value of capacitor. The next thing is required voltage rating. Accuracy or tolerance of capacitor is another factor to be considered. Stability of capacitor is expressed in long-term or short-term percentage variation of capacitive value under specified physical and electrical operating conditions. Temperature coefficient is expressed as variation in ppm, that is per unit temperature change. Leakage current flowing in dielectric at rated DC voltage at a given temperature. One should also study about the active components of the equipments. Transistors. Transistors fall in two main categories. First one is BJTs, that is bipolar junction transistor, and second is FETs, that is field effect transistors. They are also classified according to semiconductor material used, that is silicon transistors and germanium transistors. Transistors are also classified according to their field of application, like general purpose application, audio frequency application, radio frequency application, switching application. Transistor runs through some definite codes. Transistor codes have either 2 letters and 3 figures for general purpose transistors, or 3 letters and 2 figures for special purpose transistors. First letter denotes type of semiconductor material used. It indicates germanium semiconductor material. B indicates silicon semiconductor material. Second letter denotes application, that is C for low power, low frequency applications, and D for high power and low frequency applications. F for low power, high frequency applications, L for high power and high frequency applications. The third letter does not have a particular significance in case of transistors for special applications. For example, transistor AF115 is a general purpose germanium transistor for low power and high frequency applications. Transistor BC108 is a general purpose silicon transistor for low power and low frequency applications. Transistor BFY50 is a special purpose silicon transistor for low power and high frequency applications. I hope this lesson has given you a better understanding about the electronic methodology which makes the equipments work. In the next lesson, we will learn about audio consoles. We learned about the current, voltage, different components of circuits, etc.